there is a fair number of features that we still need to implement before we can put things on screen. But I want to take a moment to just look over basically put up a to-do list for what we need to happen next. I want to change our core loop so that, to begin with, we want to make it time aware. So we need to calculate a delta time. Delta time is a difference in time, so the amount of time that has passed since last time update ran. This will be a fraction of a second, and it will allow our entities to scale their velocities depending on how much time has passed. This will give us velocities in meters per second. So, calculating delta time. Then I want to update all entities with the DT. DT, by the way, should be a double because float doesn't have enough precision to allow robust scaling beyond basically half an hour somewhere. If you run for longer than that, the delta time is going to be whatever. Who cares? So, update all the entities. Then we want to add and remove entities that has spawned or been destroyed. Then we want to actually build visible set. Build a set of visible entities. So we only want to draw what the camera is currently looking at. We don't want to draw anything outside of the camera view. So this is going to need a viewport. Lastly, we want to render the visible set, and that's going to require that the entities can position themselves correctly in relation to that viewport. So the entity knows that it's in position, say, 5 meters from the start of the level and 4 meters from the top of the level, but it needs to be able to position itself in relation to the viewport and on a pixel. So we're going to have to translate the entity in the game world. So that means our render call needs to be updated. At the moment, an entity, let's see, in our static entity, does that render? Yeah, here we go. Is using its own X and Y, but these will be in meters. So this might be 1 and this might be, 5, which aren't big enough numbers, right? If that's pixel values, because we're drawing to the screen here, that's just going to put all the entities bunched up in the corner of the screen. So these need to be translated to screen coordinates, and in particular, they need to be translated into screen coordinates in relation to the camera. All of that sounds complex. It is a little bit painful, but the implementation of the drawing is trivial. We're just going to use a matrix because there are many methods, many versions of draw bitmap, and one of them takes a matrix, so we can use a matrix for the translation and use our viewport that we will write later on to build that matrix for us. Also, if you want to build a viewport, there is an article up explaining exactly how it's built. So if I go here, if you go to week number 5, implementing a viewport, here's an article explaining exactly what it accomplishes and how to build it. So go do that, and you will have it when I start showing it in the next video or in 2 videos. This should explain the details. So back to the code. Render the visible set of entities. And I think that's all we need. Then we can start building gameplay, right? We need to actually build controllers so that we can control entities and move about in the world. So yeah, calculating delta time. Let's wait with that. We want to update all of our entities with delta time, so we can do that here. We do a final double delta time. And the level manager already has a list of them, so I'm gonna just use the level. And now notice that my update assumes the level exists, right? And if it doesn't, we're just gonna crash here. Update, pass in the delta time, then we need to write that. Let's go write it. We need a public void update taking final double DT. We want a smart loop walking over the entities. I'm just going to grab this one from my cleanup method. Update, pass in the delta time, And at the end of the update step, we need to add and remove all entities. No, not all entities, add and remove entities, so that we make sure that our entities list is updated if something died or spawned during this update step. So the entities, of course, don't accept delta time at the moment, so we're going to go to the entity and update our interface here. Final double delta time, and then we have a child class that needs to be updated as well. Player update final double delta time. So basically, now if we wanted to integrate time into our velocity calculations, it would simply look like this. Our x plus equals velocity on x times the fraction of time that has passed. So by multiplying our velocity with a fraction of a second, we will always update in according to how much time has passed. We will always be moving at the correct velocity. It's not entirely robust, but it's robust enough for a simple game like ours. Anyway, we don't need motion just yet because we don't actually have in our levels anything but static entities. We're not creating the player yet. So that's the update. We are not calculating delta time. We'll get to that once we have them. So we want to be able to draw something. Let's see what the render need here. So I want to render the visible set, not all entities, only the stuff that's in front of the camera. So I'm going to give this an argument, an array list of entity, visible entities. And I'm doing an argument so that if I want to move the render method into a separate class, or if I want to run it on a separate thread, that's trivial. We simply need to create this list somehow and provide the thread with it. Later on, we want a second argument here, provide a viewport, so that we know how to translate all of the entities to their correct positions. Now then, we have a list of visible entities, so let's scroll through that for each entity. Can I make that argument final as well? That is fantastic. So we spin through all the visible entities and we call render. Then we pass in our canvas and we pass in our paint object. And we can improve this method as well. As you know, we lock the canvas first before we do any work. And if we can't, we return immediately. That's a quick bail. Then at the end of everything, we have to unlock. But if something in here crashes, throws an exception, whatever, we are up shit's creek. So we wrap everything in our render in a try. And then we don't catch, we just call finally. So a finally clause will always execute, whether there was an exception or not. Finally will execute. So this makes our code slightly safer. This is good habit. I don't like black as a background color, so I might want to have a better like sky blue or something in there. Let's see if I can remember to do this. If I make a private static, I'm going to move this up later. Final, let's call it background color. Color RGB. No. How do I get an RGB value from channels? Come on, help me out here. That's not what I want. Color from RGB. What? Come on, tooltip. Or how do I get it to show me my options? Fine. I feel like such a moron right now. Why can't I get... Well, then fuck it. We're just gonna leave it at black. No, in fact, let's then at least do this. I'm gonna keep that black. I'll change this value when I figured out what I want. Of course, that should be a color object. That might be why I don't get the tooltips. Required color. Yes, of course. Int. See? This is what I'm talking about. RGBA. RGB is all I need. That's good. That's fine. So let's do something like, I don't know, 135 and a bit of green and a little bit of blue. That should be baby blue. So just giving that a name, I can move that into a member in a little bit. We render our entities. Let's see what we have so far. And also, that's 10 minutes, all right. Render is never called. And I also don't provide a visible set, so we need to call render with level entities. Is that not public? That's private. So fugly, I make that public for now. Go back to the game, pass in all the entities. That's obviously not what we want to do. We want to build a visible set, but we'll do that later. Rebuild. Let's see how much this crashes trying to load our bitmaps. Oh, well, there we go. We have at least the background. That's a nice blue. And then the question is, why am I not seeing any entities? We might want to put, let's see, that's the render. It's called canvas and paint. So we can put a breakpoint in a static entity and then run the debugger to see if this is actually called at any point. It probably is, so I might also want to see what sprite names we're getting here. Am I not stopped? No, the debugger. Are we still building? No? What's going on? Default activity not known. Interesting. Let's see if that happens again. Might be something with my manifest. Here we go. Okay. So static entity sprite name is ground left. Let's see if that indeed works. We can step in. We can step. That's not where I want to be. It's setting up its members. Bitmap is still null. Yes, that's fine. Ah, I never call load bitmap. So that explains why we can't see these things. Also needs to see that we'd never crashed. So I'm now in static entity, the constructor. I need to call load bitmap with my sprite name and my position, which really should be floats, but let's not worry about that just now. And now we rerun. Still no art. Let's put one there to see if that's all right. Also, let's see if we have any outputs. Game thread started. Surface created. Yeah. So that seems good. I'm just gonna double check here. We are run, render. We can call update. Just pass in, 0. Doesn't matter obviously because update's not doing anything right now, but while we run update render. Am I even running? Let's put a breakpoint here. And then render. Actually, let's not do that. Let's put one in the render call instead. Run with debug. And while that's building, I want to just go check my static entity render bitmap XY and paint. Should be fine. Right, we're stuck in create entity. We don't need to look at that anymore. So continue is down here. Now we are in load scale bitmap. Continue. We are loading a bunch of these things. I look down here, I have ground right, so it's loading different things. Let's actually, no, yeah, it does load, so that's fine. Okay, yeah, that's not what I want. Continue, please. Now we're in the render call, so we know that happens. Why do I keep stepping in? That's not what I want. I want to step over. Yep. So that's happening. But I'm not seeing anything. Are they perhaps positioned behind the platform? Hang on, wait, what's the width? I am calculating width up here for my loading of the bitmap, but that's in pixels. Oh yeah, of course, the bitmap knows its own width, so that's fine. What if I hard code this? Every entity will be positioned at 100 and 100. And let's see if that works. There we go. So it was actually hiding behind the that's not the action bar. It's one of the bars. It's hiding behind one of the bars. We need to make this full screen, and also we need to actually position these things. So we can do one of those. For positioning, at least we now know that it works, right? So we don't have to run the debugger anymore. For positioning, let's make a matrix that we can use to translate our positions. So let's make a private, and I'm gonna make this the same ugly way I always do, because this is going to be rendering. Like, the render will only be called from a single thread. I can reuse the same object every time we go into this method, the same way I'm using the canvas and the paint object. Doesn't need to be static, in fact. So let's just call that transform. I should move this to the top of the class, but we'll do that later. Why doesn't it know matrix? It's not the OpenG, it's the graphics one I want. Thank you. Of course, I need to actually provide the type. There we go. So now we have a transform. Before we do anything else, we want to reset the transform. Reset. And then we want to tell it to do a post translation and a certain amount on each axis, on the X and the Y. So we do transform, post, translate, the X and the Y. So that's going to be X position, Y position in meters. So just ugly temporary method values here. These should be reused later on. Let's do a final float xpos equals, sorry, that actually needs to be per entity, obviously. This needs to be in the loop. I'm being silly. Per entity. First, reset the transform, calculate their position. So that's going to be entity X times, no, I don't have to do that. I can actually call world to screen X with the entity position. Then I want to call world to screen Y with our Y position. And then we set up the transform to do a post translate with those two values. Now, our render, of course, don't take a matrix yet, so we're going to teach it to do that. We're just going to add that as an argument in the middle, the canvas, the transform, and the paint, and go to our entity interface, go to the render call. I want a final matrix from the graphics library. Let's call that transform. And then let's bring that to our static entity. Thank you. Transform, and also to the player. Doesn't have a render, so I don't have to worry about it. And now, instead of providing coordinates here hard-coded, we can just do draw bitmap, the transform, and the paint. Let's remove that breakpoint so you can see that. And now the transform will, well, right now we've only told it to translate the entity. And maybe we want the translation to happen inside here in the render. We'll see later on. Right now I just want to see if it works at all. But this transform can do many things. If you remember from our bitmap utils, we have a way of scaling bitmaps, and we do that using a that's a point. Hang on, where's my rotation? We have a way to rotate bitmaps. We do that with a matrix. We have a way of flipping bitmaps. We do that with a matrix. So now that our entity has a transform matrix on its own, it can manipulate that however it wants. So now we have a renderer that can deal with rotations and flipping inside the render call. And we don't have to create a new object for it either. That will happen only in the frame buffer using the original bitmap object. So, what was I doing? I saw something. This is wrong. Height pixels needs to use world to screen on the y-axis. And my game is now broken. Nope, that's good. Let's build that. So, we have created a transform that we reuse. We reset it for every entity. We calculate its world and its screen position from its world coordinates. We call post-translate on the transform and pass it into the render call. And that looks like this. Hooray! So obviously this is not super useful right now, but they are positioned correctly according to whatever my map is. So if I go to test level, here we go. What we're seeing is this setup, I'm pretty sure. So we can add a few more if we wanted to. So if we do 3 and 4, and they are tiny. 1 is the player, so that's not going to render because we don't have a player entity yet. Let's add a couple of the ground there. So our viewport needs to make sure that we fill the screen. It knows both the resolution of the screen and thus can calculate how much a meter needs to be to fit correctly. Yeah, but there we go. We have positions. We are translating our matrices, our entities, so they can be rendered in the correct position. Now we need that viewport to make this sensible. I'll see you in the next video.